Alright, so fall semester review for Unit 5. Although you guys are required just to do the odds for this particular assignment, I think the first 14 or so doing both the odds and evens are going to help you understand more of the ideas, so I'm going to go ahead and do that. For number 1, what we need to know is that anytime there's a negative under the radical, we'd want to factor out an I. And then after we do that, we just want to go ahead and simplify the square root of 192. So to do that, I'm going to start with by factoring out 4. 4 goes into 192, it goes into 19 4 times, with 3 left over, and it goes into 32 8 times. And then I recognize again I could factor out another 4, that's 4 times 12. And then again, 12 factors 2, 4 times 3. So for every 4 that I have, I should be able to factor out a 2, which means I can factor out 3 2's. And 2 times 2 times 2 is 8. So problem number 1 simplifies to 8i root 3. Number 2, what you need to understand is that negative 5 squared is the same as negative 5 times negative 5. And anytime that you have two negatives under one radical, you want to multiply them first. So this becomes negative 5 times negative 5 is positive 25. And the square root of 25 is just 5. Number 3. Here's its alternate problem. Whenever the radicals are split, whenever you have two radicals, you want to pull your i's out first. So this becomes I root 5 times I root 5. When you multiply, you get I squared times the square root of 25. Anytime you see I squared, you want to substitute in a negative 1. And then the square root of 25 is 5. So this problem ends up being negative 1 times 5, which is negative 5. So when negatives are under the same radical, it's going to end up being a positive answer. When the radicals are split, like number 3, you should realize that your i's will factor out, meaning that you'll end up with a negative answer. So negative 5 for number 3. Number 4, I'm going to go ahead and factor out an I. And then the square root of 64 is 8. So your answer is 8i. Number 5. I want to go ahead and factor out an I, and then I want to simplify the square root of 8. When I do that, I get 1 over 2i root 2. So now we got to do what's called rationalizing the denominator. I'm not supposed to have i's in the denominator, so I'd have to multiply by I over I. But you also have to remember we can't have radicals. So I also need to multiply by that root 2. So to rationalize this denominator, we multiply by I root 2 over I root 2. So in my numerator, 1 times I root 2 is I root 2. And in the denominator, I get 2 times I squared times root 4, which becomes 2 times negative 1 times 2. So this becomes I root 2 over negative 4. Number 15, I'd factor out an I, or excuse me, number 6, I'd factor out an I on both spots. So I'd have I root 15 times I root 21. Then I'd go ahead and multiply. It'd give me I squared times 15 times 21 under the radical. You can go ahead and multiply that out, but I like to go ahead and just factor that. 15 is 5 times 3, 21 is 3 times 7. So since I have a pair of 3's under my radical, I can factor out a 3. Remember, the I squared becomes negative 1. And 5 times 7 is 35. So this answer becomes negative 3 root 35. Number 7, factor out your I. Go ahead and multiply. It becomes I squared times the square root of 20. And so this becomes 2 times I squared, which is negative 1. And so you get an answer of negative 2 root 5. Number 8. Whenever we have a square, we could use a power to a power rule, meaning we'd want to distribute in the negative or the 2 to each of those exponents. Or you can think of this as 5i root 3 times 5i root 3. When you do that, you multiply the 5's. 5 times 5 is 25. I times I is I squared. And root 3 times root 3 is 3. So now we'd want to go ahead and substitute. I squared is negative 1. And then you would go ahead and multiply. 25 times negative 1 times 3 is negative 75. Number 9, we want to rationalize the denominator, so we multiply by I over I. You don't need to multiply by 2i over 2i. The only thing that's the problem here is the I, so that's why we multiply by I over I. When you do that, you get negative 8i over 2 times I squared. This is where we substitute. I squared is equal to negative 1. So it's 2 times negative 1. So we get negative 8i over negative 2. And then a negative divided by a negative is a positive. And 2 goes into 8 4 times. So number 9 simplifies to 4i. Number 10. We'd want to factor out an I, so we get 3 over I root 5. And again, we want to rationalize our denominator, so I need to multiply by I root 5 over I root 5. Multiply the numerators, you get 3I root 5 in the numerator. And in the denominator, you get I squared times root 25. So that becomes negative 1, because I squared is negative 1, times the square root of 25. So it's negative 5. And since nothing reduces with the numerator, that would be our final answer. Number 11, what we need to remember is that I is equal to I squared is equal to negative 1, I to the third is equal to negative I, and I to the fourth is equal to 1. So it's I1 negative sandwich was kind of the rule that we remembered. And so for problem number 11, what we want to do is substitute in for I to the third. I to the third is equal to negative I. So 4 times negative I is negative 4i. Number 12, what we need to remember is our exponent rules. When we multiply two variables of the same base, what we do is we add the exponents. Oops. So this would be I to the 3 plus 5, which is equal to I to the 8th. And so what we need to understand is that since 4 goes into this evenly, I could rewrite this as I to the 4th times I to the 4th. And I to the 4th is equal to positive 1. So for each of those, I to the 4th is equal to 1, and I to the 4th is equal to 1, and 1 times 1 is 1. So the answer to number 12 is 1. Now, if you had a problem like, here's an extra example, if you had something like I to the 27th, what we wanted to do, the rule was to take the 27 and divide it by 4. So 4 goes into 27 6 times, with a remainder of 3. And the rule was that what 4 goes into it's not really the important part. The important part is what the remainder is. So I to the 27th is equivalent to I to the 3rd, because that's how much remainder is left. And then what we need to do is understand that I to the 3rd was equal to negative I. So we went over quite a few of those in the unit. I hope that brings back your understanding of it. If not, please ask questions in class so I can help you with that. Number 13, factor out your i's. Simplify your radicals. So this becomes 3I root 5 minus 2I root 5. And now because both of them have an I root 5, it's like terms. So 3I root 5 minus 2I root 5 is going to be 1I root 5. Or simply said, just I root 5. Because 3 minus 2 is 1. Number 14, we'd want to distribute in this 2i. So 2i times 5i is 10i squared. 2i times positive 7 is 14i. Now remember, anytime we see I squared, we want to substitute in a negative 1. So this becomes negative 10 plus 14i. Remember that the I part is always written last, because in complex numbers, it should be in this form, a plus or minus bi. So the imaginary part's always written last. Number 15, basically we just need a FOIL. First, 3 times 2 is 6. Outer, 3 times negative 5i is negative 15i. Inner, which is 12i. And last, positive 6 times negative 5i, positive 6i times negative 5i is negative 30i squared. Now, anytime we see I squared, that's the same as a negative 1. So negative 30 times negative 1 is going to be positive 30. So this is going to be 6 minus 3i plus 30. Combine your like terms, and you get 36 minus 3i. Number 16, what we need to remember is that we always need to FOIL. When we have binomials squared, it means we want to multiply 4 plus 7i times 4 plus 7i. Then we'd FOIL first. 4 times 4 is 16. Outer, 4 times 7i is plus 28i. Inner is another 28i. And then last is going to be plus 49i squared. Now remember, I squared becomes negative 1. So this is the same as 16 plus 56i minus 49. So then we would go ahead and take the 49 and the 16 and subtract it. And because the 49 was negative, your answer should be negative 33 plus 56i. Number 7, another foiling issue. So 2 minus I times 2 minus I. We'd want to FOIL it. First would be 4. Outer would be negative 2i. Inner would be negative 2i. And last, negative I times negative I is positive I squared. I squared becomes negative 1, so this is 4 minus 4i minus 1. Combine your like terms, the 4 and the negative 1, so this is 3 minus 4i. Number 18. Now we have i's in the denominator, but what you need to understand is that there's two terms there. That's a binomial. So to rationalize binomials, we need to multiply by the conjugate. The conjugate of 3 plus I is 3 minus I. So I want to multiply the top and the bottom by 3 minus I. Now remember, you're going to have to FOIL. So FOIL the top. I'm going to go ahead and do some scratch work down here at the bottom. 4 minus I times 3 minus I. First, 4 times 3 is 12. Outer, minus 4i. Inner, negative 3i. Last, is negative times a negative is a positive, and I times I is I squared. So this is 12 minus 7i minus 1, because I squared is negative 1. When we go ahead and combine like terms, we're going to get 11 minus 7i for our numerator. Now go ahead and take the denominator and FOIL that. 3 plus I times 3 minus I. 3 times 3 is 9. 3 times negative I is negative 3i. Inner is going to be positive 3i. And last is going to be negative I squared. So the positive and negative 3i are going to eliminate. And since I squared is going to become negative 1 and a minus is going to become a positive 1. So after I FOIL 3 plus I times 3 minus I, I'm going to get 9 plus 1, which is 10. That is your answer. Now be aware that on your test they sometimes split the denominators, so also you could be looking for 11 over 10 minus 7i over 10. These are both equivalent answers. Be aware of both possibilities on your test. Number 19, we want to plot. What we want to remember is that the real part is kind of like our x, and the negative 3i is like our y. So when we graph this, typically in a coordinate plane, this would be my x-axis, and this is going to be my y-axis. But when we're graphing complex numbers like 2 minus 3i, the x-axis is called our real axis, and the y-axis is called our imaginary. So we want to graph this just like an x and a y. The real part is 2, so I'd want to go to positive 2 on my real axis. And my imaginary part is negative 3i, so then I'd want to go down 3. So this point right here is 2 comma negative 3i. That's how you'd graph it, or that's how you'd pick it out on a multiple choice test. Number 21, we'd want to go ahead and solve. It says solve by completing the square, so I have to do this a certain way. The first thing I do is subtract 10 from both sides, so I get x squared minus 20x is equal to negative 10. Now I'm going to go ahead and do this in a different color. To complete the square, I want to do b divided by 2 squared. So my b value here is negative 20. I want to divide that by 2 and then square it. So that's going to be negative 10 squared. Negative 10 squared is positive 100. So I want to add 100 to both sides of the equation. I see a lot of you make a simple mistake by not adding that number to both sides. It's very important. That's what you need to do. So the reason we do that is so that when I factor, The left side, this becomes x minus 10 times x minus 10. You can go ahead and double check that work, but that's what it becomes out to. And so we can rewrite this as x minus 10 squared. On the right side, negative 10 plus 100 is 90. So now as you can see, I get x minus 10 squared equals 90. To undo a square, we take the square root of both sides. So this becomes x minus 10 equals, remember, when you take a square root, you have to add plus or minus the square root of 90. We can go ahead and factor the 90 now. It's 9 times 10, so you can see you can pull out a 3. So this becomes x minus 10 equals plus or minus 3 root 10. The last step is to add 10 to both sides, and when you do that, you get 10 plus or minus 3 root 10. That is your answer. You cannot combine the 10 and the 3. These are not like terms. You can't add 10 to 3 root 10. Okay, so that is your final answer. Number 23, solve for x. It doesn't tell me how to solve it, but since this equation is equal to 0, we need to go ahead and first check to see if we have a greatest common factor. There is. I should be able to factor out a 9. When I do that, it becomes 9 on the outside of the parentheses and x squared minus 4 inside the parentheses. Now what we want to do if we're solving for x, since there's a number on the outside of that parentheses, I could divide both sides by 9. So this becomes x squared minus 4 is equal to 0, because 0 divided by 9 is 0. Now we'd go ahead and do our difference of squares. It would be x plus 2, x minus 2. And so by zero product property, x is equal to negative 2 or positive 2. Number 25. I have an x squared, but I don't have any x's. So really all I need to do is try to get the x's all by itself. To do that, I want to subtract 40 from both sides. So I get 3x squared is equal to negative 36. Now I'd want to divide both sides by 3, so I get x squared is equal to negative 12. Now to get x all by itself, I take the square root of both sides of the equation, but when I do that, I have to add a plus or minus. Now as you can see, that was a negative 12, so since there's a negative under my radical, I'd want to factor out an I, and then I'd want to simplify that radical. So x is equal to plus or minus 2i root 3. The square root of 12 is 2 root 3, but since there's an I out there already, it becomes plus or minus 2i root 3. 27. So what we want to do here is factor. So how do you get x to the fourth? What times what gives you x to the fourth? What you need to recognize here is that x squared times x squared is equal to x to the fourth. Now I look at this second operator, and since it's negative, 1 is going to be plus and 1 is going to be minus. And now to get 24, it's either 1 times 24, 2 times 12, 3 times 8, or 4 times 6. Now which one of those is going to give me potentially a negative 5? Exactly, the 3 times 8. Do I want the 8 to be positive or negative? Negative. So x squared plus 3 times x squared minus 8 is going to give us the x to the fourth minus 5x squared minus 24. Since I've factored it, now I want to use zero product property. So x squared plus 3 is equal to 0, or x squared minus 8 is equal to 0. And then we want to solve for x, so we would subtract 3 from both sides on this left equation. Then we would go ahead and take the square root. When you take the square root, you have to make sure you add a plus or minus. Now I see that there's a negative under that radical, so I'd want to factor out an I. So 2 of my answers are going to be positive I root 3 or negative I root 3. I go ahead and work on the other equation. I add 8 to both sides. Then I take my square root, so x is equal to plus or minus the square root of 8, so x is equal to plus or minus 2 root 2. So there are actually 4 answers here. Number 29, first thing we need to understand is that this square of a binomial means that I'm supposed to FOIL. Never distribute over an addition or subtraction sign. Whenever you square a binomial, it means you're supposed to FOIL. So we need to FOIL x minus 4 times x minus 4 first. When you do that, you're going to get x squared minus 8x plus 16. So the first step is to FOIL the x minus 4. Now I'd go ahead and distribute in the 6. When I do that, I get 6x squared minus 48x plus, let's go ahead and do some scratch work over here, plus 96. And now I distributed in the 6. I can go ahead and drop the parentheses, so there's a plus 1 out there, and then equals 37. Now I would go ahead and combine like terms. So I get plus 97 equals 37. Now I would go ahead and subtract 37 from both sides to set it equal to 0. Remember, if we're solving for x, we need to set it equal to 0. So 6x squared minus 48x plus 60 is equal to 0. As you can see, the coefficients are 6, 48, and 60. Hopefully you can recognize that you should be able to factor out a 6 at this point. And just like we did in a previous problem, whenever there's a number in front of there, we can divide both sides by that number to get rid of it. And then we need to solve for x. So try and factor this. It's not possible. Okay, the only way to get 10 is 1 times 10 or 2 times 5. We're not going to get the middle term we need. So you have two choices. You can either solve this problem by completing the square, or you can use quadratic formula. If you're going to use quadratic formula, it's negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm going to go ahead and use the completing the square method on this one. So the first thing I'm going to do is add 10 or subtract 10 from both sides, excuse me. Now I'm going to go ahead and do my completing the square. Completing the square is my b value, which is negative 8 divided by 2 squared. When I do that, I get negative 4 squared, which is equal to positive 16. So I want to add 16 to both sides of my equation. When I do that, the left side is factorable. It's x minus 4, x minus 4. So this becomes x minus 4 squared is equal to 6. So to solve for x now, we would take the square root of both sides. So I get x minus 4 is equal to plus or minus the square root of 6. Always make sure you add your plus or minus. And then the last step is just to add 4 to both sides. So if you did the quadratic equation, you should end up with 4 plus or minus the square root of 6.